with Princess Aurora.
Aurora? She's very beautiful, isn't she?
Yeah, she is. I love her hair.
Hurry along, girls. This is so exciting. Oh my, where are we going now? Shh. Why so hush-hush, child? I have a surprise. It's Philip's birthday, and I'm throwing him a party.
But my favorite princess is Cinderella.
No, Aurora is my favorite.
Up to you.
Aurora, I wish Princess Aurora is here in her real life.
Did you know that Aurora exists in the real life, really?
Really?
Of course.
Where is it? Where is she?
No, it's not human.
So, what is it?
Aurora is, I call it a magic light in the North Pole.
North Pole?
Yes, North Pole or South Pole. It happened because the electromagnetic of our Earth.
I want to go to the North Pole, but it was so far, Aurora.
Don't be sad. If you want to saw it, you can saw the video.
Is it your flash disk?
Yes.
Okay, let's see the video together.
Let's
Every second, 1 million tons of matter is blasted from the sun at a velocity of 1 million miles per hour, and it's on a collision course with Earth. But don't worry, this isn't the opening of a new Michael Bay movie. This is the journey of the polar lights.
The northern and southern lights, also known as the Aurora Borealis and Aurora Australis respectively, occur when high-energy particles from the sun collide with neutral atoms in our atmosphere. The energy emitted from this crash produces a spectacle of light that mankind has marveled at for centuries. But the particle's journey isn't just as simple as leaving the sun and arriving at Earth. Like any cross-country road trip, there's a big detour and nobody asks for directions. Let's track this intergalactic voyage by focusing on 3 main points of their journey: leaving the sun, making a pit stop in the Earth's magnetic fields, and arriving at the atmosphere above our heads. The protons and electrons creating the northern lights depart from the sun's corona. The corona is the outermost layer of the sun's atmosphere and is one of the hottest regions. Its intense heat causes the sun's hydrogen and helium atoms to vibrate and shake off protons and electrons, as if they were stripping off layers on a hot, sunny day. Impatient, and finally behind the wheel, these free protons and electrons move too fast to be contained by the sun's gravity and group together as plasma, an electrically charged gas. They travel away from the sun as a constant gale of plasma, known as the solar wind. However, the Earth prevents the solar wind from traveling straight into the planet by setting up a detour, the magnetosphere. The magnetosphere is formed by the Earth's magnetic currents and shields our planet from the solar winds by sending out the particles around the Earth. Their opportunity to continue the journey down to the atmosphere comes when the magnetosphere is overwhelmed by a new wave of travelers. This event is coronal mass ejection, and it occurs when the sun shoots out a massive ball of plasma into the solar wind. When one of these coronal mass ejections collides with Earth, it overpowers the magnetosphere and creates a magnetic storm. The heavy storm stresses the magnetosphere until it suddenly snaps back, like an overstretched elastic band, flinging some of the detoured particles towards Earth. The retracting band of the magnetic field guides them down to the aurora ovals, which are the locations of the northern and southern lights. After traveling 93 million miles across the galaxy, the sun's particles finally produce their dazzling light show with the help of some friends. 20 to 200 miles above the surface, the electrons and protons meet up with oxygen and nitrogen atoms, and they sure are happy to see each other. The sun's particles high-five the atoms, giving their energy to the Earth's neutral oxygen and nitrogen atoms. When the atoms in the atmosphere are contacted by the particles, they get excited and emit photons. Photons are small bursts of energy in the form of light. The colors that appear in the sky depend on the wavelength of the atom's photon. Excited oxygen atoms are responsible for the green and red colors, whereas excited nitrogen atoms produce blue and deep red hues. The collection of these interactions is what creates the northern and southern lights. The polar lights are best seen on clear nights in regions close to the magnetic north and south poles. Nighttime is ideal because the aurora is much dimmer than sunlight and cannot be seen in daytime. Remember to look up at the sky and read up on the sun's energy patterns, specifically sunspots and solar flares, as these will be good guides for predicting the auroras.
So, this is the aurora in the real life?
Of course.
Oh, Aurora, it is so beautiful. It is more beautiful than Princess Aurora.
I agree with you. So that's why, Finn, we have to thank to God that He had created Aurora, the great phenomenon.
Thanks God for this phenomena. I can see the beautiful of the aurora. Hi, I'm Alfina and
I'm the Haura.
We are from 13th Accelerated Generation of SMA Plus Negeri 17 Palembang. Thanks for watching. Bye.
I am not the kind of girl who should be rudely barging in on a white veil occasion, but you are not the kind of boy who should be marrying the wrong girl.